everyone, this is video 7 for lesson number 3, atoms and molecules. Till now we know what are atoms, how do atoms exist, and we have also learned how to write the chemical formula. Related to that, we have learned the valencies and the atomic masses also of different elements. Now we will continue with the remaining part of the chapter, the mole concept. These all terms are new for you. So first we will discuss about the molecular mass, formula mass. Then we will come to mole concept where we will learn about Avogadro's number and molar mass. So let's start. What is a molecular mass? Molecular mass is the sum of atomic masses of all the atoms which are present in a molecule of a substance. For example, molecular mass of water will be 2 of hydrogen atoms plus 1 of oxygen atom. Atomic mass of hydrogen is 1. Since there are 2 atoms, so we will be writing 2 into 1 plus 1 because oxygen is 1 atom is here, so 1 into 16, that is atomic mass of oxygen. This will result in 2 plus 16, that is 18U. Similarly, molecular mass of carbon dioxide, see 1 atom is there, and for oxygen there are 2 atoms. So 1 into 12 plus 2 into 16, it will come out to be 44U. Same way you can see the molecular mass of methane, that is CH4, 1 of carbon atom and 4 of hydrogen atom. So it will be expanded as 1 into 12 plus 4 into 1, that is 16U. Sometime you will see this term also, formula unit mass. It is again the sum of the atomic masses of all the atoms which are present in the formula of a compound. Okay, we are just adding it here because it is consisting of different ions. Okay, and here the ions are forming the compound where we are calculating the formula mass. Let's see the example. Formula unit mass of ZnO, that is zinc oxide. 1 atom of zinc combining with 1 atom of oxygen. We will simply do 1 into 65 because 65 is the atomic mass of zinc plus 1 into 16, that is 81U. Same way you can see these other examples, sodium oxide and potassium chromate also. Okay. Next we come to the mole concept. What actually the mole is just a unit which was introduced around 1896 by a scientist named Oswald. He derived this name from a Latin word where moles mean heap or pile. Okay, a substance can be considered as a heap of atoms or molecules. Thus, what actually mole is? Mole is of particles which may be atoms, ions or molecule is the amount of the substance which contain same number of particles which are present in 12 gram of C12 atom. Okay, means it is saying that mole is just a reference unit. It is considering 1 mole is equal to the number of particles which are present in C12 atoms of the carbon. It can be electrons, it can be atoms, it can be molecules, anything can be there. Okay, and that number is equal to 6.022 into 10 raised to the power 23, and this number is called Avogadro's constant or Avogadro's number, and it is represented by NO or Na. So in terms of number, if I am saying 1 mole, it means 6.022 into 10 raised to the power 23. If I say 1 mole of bananas, so what does it mean? What is its number? Its number is equal to 6.022 into 10 raised to the power 23. Okay. Same way, It is taken from, name has been taken from scientist name Amedeo Avogadro. And you should always remember this, that 6.022 into 10 raised to the power 23, it can be atoms also, molecules, ions, electrons, or anything else. If I am saying 1 mole, then the number is always equal to 6.022 into 10 raised to the power 23. Okay, let's make it more easy for you. 1 mole of atoms of oxygen contains, because just now I said 1 mole is equal to, it is this much, 6.02 into 10 raised to the power 23 atoms. If I say 1 mole of oxygen molecules, then again it will show the same thing, 6.02 into 10 raised to the power 23 molecules of oxygen. But when we are talking about molecule, we know that 2 of atoms have combined to form a molecule. So it will be equal to 2 into 6.02 into 10 raised to the power 23 atoms, because each molecule of oxygen contains 2 atoms of oxygen. This was in number, but what about in mass? If I say 1 mole, number you know it is 6.022 into 10 raised to the power 23, but mass, somewhere you may be needing mass also, then 1 mole is exactly equal to the atomic mass in grams of that element. Whatever the atomic mass is, it is the mass of the element in mole. Suppose atomic mass of aluminium, you know, it is 27 AMU, that is atomic mass unit, and 1 AMU, this we have derived, you know this, is equal to 1.66 into 10 raised to the power minus 24. Therefore, 1 mole of aluminium will contain this much atoms. This we know, just now we have studied. Mass of 1 atom of aluminium will be equal to 27 into 1.66 into 10 raised to the power minus 24 grams. Okay. Therefore, mass of 1 mole of atoms will be equal to 27 into 1.66 into 10 raised to the power 24 grams into 6.02 into 10 raised to the power 23, that is equal to 27 grams. Now, how mole Avogadro's number and atomic mass is related? See here, 1 mole of carbon atoms, if I say, then it means it is containing 6.022 into 10 raised to the power 23 atoms, and it is weighing, the mass of 1 mole of carbon is 12 gram. Similarly, 1 mole of hydrogen atoms, number how many atoms are present here? Again it is 6.022 into 10 raised to the power 23 atoms are present, and what will be the mass? The mass is 1 gram. So 1 mole of any particle, it may be atom, molecules or ions, will always have the number 6.022 into 10 raised to the power 23, and mass will be always be equal to the relative mass of those particles. 1 mole of molecules, if I am talking, then again the number is same, 6.022 into 10 raised to the power 23, and if I talk about its mass, then it will be its molecular mass. Wherever the atoms are there, it is having atomic mass. Wherever atoms are combining to form molecules, then we will consider 1 mole of molecules is equal to the molecular mass in grams. What happens if mole is asked in terms of volume? So it says that it is equal to 22.4 liters at STP. STP is standard temperature and pressure. That is equal to temperature 0 degrees Celsius and pressure of 1 atmosphere. So we use this because molar volume allows the conversion to be made between moles and volume. Suppose you are giving moles and volume is there, then you can easily calculate the unknown value from there. Now let's quickly revise some of the formulas which are important for understanding the mole concept. Once again I am repeating, 1 mole of a substance is always equal to 6.022 into 10 raised to the power 23 particles. It can be atoms, molecules, electrons, ions, anything. Now, when you have to calculate the number of moles of a substance, so how you will calculate? Mass of the substance in gram, which is given, and mass of 1 mole of a substance in gram. Mass of the substance upon mass of 1 mole of substance in gram. That is, small n is representing here the number of moles, small m is mass of the substance, and capital M is mass of 1 mole of substance in grams. If you have to calculate the number of moles, then how you will be calculating through these numbers? Number of particles upon Avogadro's constant. Okay, it can be written like this also. Small n is equal to capital N upon Na. Well, small n is number of moles, n is number of particles, and Na is Avogadro's constant. You know this. And suppose if you have to calculate the number of particles, then again you can easily calculate by multiplying number of moles with the Avogadro's constant. Okay. This one more relation that comes out from their number and mass is this: number of particles upon 6.022 into 10 raised to the power 23 is always equal to mass of substance in gram upon mass of 1 mole of substance in gram. So from these 4 values, if any one is unknown, you can calculate by comparing both moles in terms of number and moles in terms of mass also. Okay. Mass of one atom of an element is equal to gram atom of an element upon 6.02 into 10 raised to the power 23. If you have to calculate the mass of one atom, it can be calculated by using this formula. Let's see some of the numericals. Mass of one atom of oxygen. Just now I have told you that 1 mole of oxygen is equal to 16 gram. From where the 16 has come? Because 16 is its atomic mass. And it is also equal to 6.022 into 10 raised to the power 23 atoms. So mass of one atom of oxygen is equal to 16 upon 6.022 into 10 raised to the power 23. That will be 2.65 into 10 raised to the power minus 23. Same way, mass of one molecule is equal to, because molecule means 2 atoms are combining, mass is equal to 32 U. Okay, mass of 1 mole of oxygen, again 32, because you know that oxygen gas exists as O2, 2 atoms are combining, and by this you can calculate. Now number of moles you know, weight upon your whatever the weight is given upon the molecular weight. 4 gram of helium. You know the 4 gram of helium is given here 4 upon, you know, the molecular weight, the atomic weight of helium is 4. So that is 1 mole is the answer. 46 gram of sodium. 46 is the given value and the atomic mass of sodium is 23. It is representing here 2 moles. If the question is 0.40 gram of calcium, so how many moles it is going to form? You will solve it 0.40 upon 40, because 40 is the atomic mass of calcium, that is 0.01 mole. 12 gram of helium, again 12 upon 4, because 4 is the atomic mass of helium. You will get the answer 3 moles. Thank you so much. This much for today. Rest we will continue in our next slide. Thank you.